So first of all, I would like to thank the organizer for inviting me in this faculty development program in AICT, online faculty development program on security and privacy issues and their countermeasures in the era of artificial intelligence. As mentioned, it has been mentioned that the title of the talk is the Deceiving AI and Adversarial Attacks and How to Stop Them. So in this particular lecture, we are going to discuss basically going to discuss a few issues. First, we took basic introduction. What do you mean by an adversarial attack? It's basically means, or it's popularly known as adversarial perturbation, and what in defense against this adversarial attack. Then we going to understand the major application areas where this adversarial perturbation is basically a threat, mainly in the computer vision based deep learning models. So we'll see pattern recognition, remote sensing, autonomous vehicles, facial recognition, etc., etc. Then we try to understand what are the basic idea of what the attack models and the defense policies to prevent and countermeasure against these attack models, and a very brief overview of our research at Multimedia Lab in IIT Guwahati. So first, before I start, I very briefly said what we are and what we are doing in our lab. My name is Arijit. I'm the professor at Department of CSE IIT Guwahati, and I did my PhD as mentioned from IIT Kharagpur. And this is the very brief overview of what we are doing at this moment in our lab. So it is a image video restoration. What is basically a kind of denoising kind of thing, days in the Then underwater vision, we have a very big project on that vision. And remote sensing, zero-shot learning, then adaptive video streaming, satellite imaging, medical imaging. So there is so many groups in our lab, and mainly what is important today's talk, we had a DST project on adversarial perturbation, and for the last few years we are doing some work on this. So today's talk, we basically trying to say that what are the basic aspects, very ground level aspects of adversarial perturbation, and trying to do some sort of discussion on these particular research topics. Okay. So let's start. So first to understand what is the adversarial perturbation. Okay, as we all know that machine learning is now become a very important aspect everywhere. So just a second. I just turned off my camera due to if there is any issue. So is it completely audible and screen is visible?
Yes, sir, screen is visible and you are audible, sir.
Thank you. Okay, let me. So, so the basic idea is that that whatever we are doing in different computer vision task, that may be I'll coming one by one in next two slides. So machine learning is used to predict, to analyze, some to generate different task. So as we know, there is a different machine learning task, which is maybe supervised, where a examples or annotated examples have been given, and sometimes it is unsupervised, no labeled data has been given. So other variants of this unsupervised, that is semi-supervised and supervised, and another is reinforcement learning. So these are the types of machine learning. And generally, what happened in machine learning driven inference system, that input is being given to the machine learning. Input means what? Input means basically I input as an image or video, and then we extract some feature. In conventional machine learning, this extraction is basically the features. We say that feature engineering or kind of feature extraction kind of, and these features are being extracted from the images or videos and is fed to the different classifier, okay, and regressor, whatever. These classifiers, maybe in lot of classifiers, we know that for linear, from linear regression to logistic regression or classification, and then support vector machine, neural net, and so on. Nowadays, another very important, like deep neural network, that means number of hidden layers is too many. That kind of neural network is in very popular. Basically, it superimposes the that supersedes the different so in general, that our this kind of machine learning algorithm has a two major phase. One is training phase, and another is just a second. So as what we were discussing, that in this particular training phase, we learn the model. That means, what you mean by learn the model? We know the parameters. This model is basically parametric models, and we know the parameters or weights, biases, and some hyperparameters also, that we tune these hyperparameters so that we can map from input to the output, so that we can give in an input and what is our desired output, our model can answer this. And testing phase is basically that. What? For the unseen data, but data is not being used to train, that data are being given. So our actual concern is that model, what is being trained, it is being basically giving is the correct answer or desired answer. So this is the basic idea of machine learning. I'm not going details because the intention of today's talk is completely different. That okay. So if you see that ML is everywhere in our, so ML, or you can say this modern part, the deep learning is everywhere. So you can say from healthcare, so some sort of same kind of other facial recognition, image recognition, autonomous driving, satellite imaging, then medical imaging, and in kind of market strategy, prediction, kind of, and every optical character recognition. So this is a very few examples. So everywhere now there's ML algorithm. Basically we restrict in the vision task because our today's talk is on the vision related thing. So we can say that machine learning becomes a part of our daily life. Okay. Now we come to what is come to the exact today's topic. What we actually mean by this adversarial perturbation. So adversarial perturbation is a kind of attack. That attack is basically the harm this model, this machine learning model, as well as deep learning. So what actually being done in this adversarial perturbation is that there is a X input image. You can say it's a panda input image, and your classifier can say that it has been trained such that it can say, okay, it is a panda, maybe some particular confidence score. Okay. So what is adversarial perturbation? A very less noise. You can say that this noise pattern is being injected, or here it is a additive noise is added to this. It is added in such a way that this in human eye, this panda image look like as it is. So human always say that, okay, no, it is a panda image, but these particular images become such vulnerable, or this kind of this noise is such that so the model what is being trained is going to misjudge it or misclassify it. Okay, so it say no, it is not panda, it is basically gibbon. So this particular concept is first kind of invented, or is said by Goodfellow and et al. In their very seminal paper, this on ICLR 2015. Okay. So what actually this happening here? You can see here that it is saying that we are saying this is a given image, but your model, by virtue of this addition of this noise, it is say no, it is not a panda, it's a gibbon. So it basically nullify the main aspect of the classification or inference. Okay, so this is basically called adversarial perturbation, or it is called adversarial attack, that nullifies, or that is substantially degrade the classification or inference quality of a particular machine learning or deep learning model. Okay, so we try to understand how these kind of images are being perturbed, and what are the ways we are going to do this, and what are the countermeasures on what we. So this is the agenda of this talk. Okay. Okay. Now we are going to say the similar thing here, that adversarial perturbation is basically the incorporation in low magnitude additive noise. That what I'm saying, this additive noise is very low magnitude, that it is human imperceptible to the human eye. Okay. So that deep neural network or the shallow anyway forcefully make the incorrect prediction. Here you can say that it is a just is a bird, we are it a bird, but it is misclassified as a snake. That it's basically a parachute, it misclassified a pillow, and this is basically bell paper, and it's basically this is called the strainer, so on. These are the basic idea. So this impact every aspect of computer vision application. Now you can see what happened. Why this attack is so problematic, so kind of a big threat. Now you can just consider the automatic vehicle scenario where there is some vision classifiers as basically, or a camera is basically built on this car or vehicles, that it basically see the traffic signal. Now, if there is a traffic signal is red, it's supposed to push the brake and stop. But if you put some this kind of adversarial examples or adversarial noise, such that this traffic signal, even human we are seeing it's a red, but when the machine model it is basically seen as a, okay, it is a 30 km/h. So what happened? There will be a definite collision. So this kind of a sensitive system, even you can say that what can be done in medical imaging. Medical imaging, this will become very sensitive issue, become a catastrophic failure. And so on, this pedestrian, road, tree, traffic sign, object face, anywhere we can do it, and and the result is very dangerous. And it substantially degrade the whole system, the performance of the whole system. So the adversarial perturbation is a very significant attack. Okay. So basically, the definition as a definition of this attack would follow in 2070. Adversarial example inputs. Adversarial examples will come later. That what example means, what we'll see here, that these are the adversarial example, that this particular image, after injecting the noise to the actual image, this is perturbed image called adversarial example. So here the adversarial examples are input to the machine learning models that an attacker has intentionally designed to cause the model to make a mistake or a false decision or inference. Now here this diagram I've taken for this paper. So it's a very interesting kind of diagram. You see what actually happening, what I'm starting. I have started with this particular thing in our different application areas like malware detection, autonomous vehicle speech, and so on, etc. What user is basically doing, it predict the prediction of the input. That is the basic idea. So that's why they train the model. So these are the neural, this kind of machine learning models. It is SVM, neural net, now clustering, whatever is the model. And in general, when there is nothing problematic, they got the output, and most of the cases they got the right and what the intended output. Now, what is done by the adversarial? That adversary put some inputs to these particular images. Whatever images they are, there is a different way of doing. We'll come this thing, that what are the different ways of doing this. So that this model is basically going to give a wrong output to the basically users or attacker people. So these are the basic idea what we have already discussed. Now the question is that how people are doing this. That is we are going to try to understand at least briefly in this today's lecture. There is a different kind of way. Just for example, that for this is the just example. Come again. What? So model extraction attack. Model extraction attack. This means basically they are stealing the model. That means they try to understand what are the different parameters, because these models are all a parametric model. So if we can know that this parameter hyperparameter, so we can reverse engineering the model, and then we do some wrong in this model so that this model can be used. So this is a model extraction attack. Poisoning attack means basically they poison the data. We already said that this is poison the data kind of. Model inversion attack is basically that they're not changing this, but they're trying to find out what are the input output. They finding the output that they kind stochastically basically predict the input. So this kind of way are basically being employed for this kind of trade. So one by one, in this very short time, how much it's possible, try to our best to understand this other. But before that we have to some idea that what kind of effect that were in this classification accuracy is Google Net on MNIST. Subsequently, this substantially downgraded. You can see this is basically, if noise in being inverted, still it's a 98%. But this kind of FGSM, this is a very important attack, and projected PGD, this is projected gradient descent. This kind of, now you can see that how seriously it has been dropped. This is 18%. This is 1%. So you can see that the 98 to 18% or 1%. So it's a deep full attack. This is basically 1%. The deep full is a very well-known attack nowadays. This helps. So we that can summarize here. You can see that what these are the actual images, and your normal network, your what is the network which not been attacked, it is going to predict in this way that this is liar with a confidence 4.99 or 99%, or it's a race car, it's a 74% and traffic signal. So it is the benign case, or is a not attack rate. But if some attack is done, then this category, this lion is being termed as a pelican with 97% confidence. So that is completely, this DNA is completely destroyed, or it is very much doing the wrong classification. Same as sorry, this car is termed as a speedboat, and this traffic signal is basically the genes, and with such a very high confidence score, it has been misclassified. Okay, so here but you can see that almost there is a negligible type of noise. It is a human eye, we cannot differentiate between these two. So that is the major aspects. Okay. Now here it is a basically a semantic segmentation kind of thing, that you can say this is semantic segmentation, is a pixel by pixel we classify per image. Generally it is given that this original image, that is the, but if you do it adversarially, you can get this kind of, that is basically a completely missed or completely wrong output. So this kind of okay, this is also the sports ball. It is basically stop sign, but it is classified as object detection. It is classified as a sports ball. 80%. Here, this application, this is a stop sign, but if you put a noise here, it is the here it is this kind of this kind of stop. So these are the basic example. I think understand the basic idea of what adversarial perturbation is. And here another example, we can say this is a very important example because we have a surveillance video or surveillance images with the face recognition system. You can see we put some noises in this spectacle, and this fake space is basically recognized as a completely different person. So this is the kind of examples that is very, very harmful, or this is very, very big threats over the machine learning or deep learning based system. Here basically a kind of image is a medical image. It is basically a benign thing, but if you put the noise, this is no, it is not benign, it's malignant kind of. So this red means malignant, so it's detection. So these are the basic things. So you can find these papers also where this kind of discussion literature you can find. Okay. So with this, this is the just a very brief introduction. So what is the adversarial perturbation is means, what is the threats, how people are basically. But next, to understand what is the defense, how we can counter this problem. Okay. Now, as we understand that if we add noise, that panda image is recognized as the given image, that you understand. But it is possible that some defense mechanism can be imposed, so that again this given image is given to the sub framework, and then again if it is fed to the same classifier, it is basically kind of, you can say, kind of denoiser. We have also worked on this particular issue, that can be possible to denoise a given image that is partially the adversarially perturbed to go back to the actual image. Okay, so this is some very common thing also help, that is image compression, randomization, random padding, adversarial training, and so on. Kind of adversarial training will come. It's very interesting kind of defense mechanism. Then GAN-based kind of techniques. So we'll see that. So here, so what we're going to understand, that this is a dog image. It is based that this kind of dog is classified wrongly. But if we do some real-time compression preprocessing, some vaccinated means the neural net is trained such a way it not easily fooled by this, or is not really regretted by this adversarial example. Come these things also, but this is called vaccinated neural network or enzyme, so that it correctly classified. Okay, so that is kind of, this is just the concept. Will come, how will come later. So okay. Now, but this is not a very easy task. It is said that it is doable, but there is some very important challenges, or very heavy challenges we have to face, because attack type are different. Okay, it's a lot of different attack type, and we have to against these diverse attacks. Okay, diverse type or different types of attacks. Okay. Now the models also is different. So different kind of models are there. So we have to find out that depends for this kind of models. Now, what are the other challenges? The defense mechanism should not make the models is very computationally intensive. That is one challenge. Not so much. It should not be like this, that you are doing some sort of defense mechanism, so the model's main agenda is changed. So control updates, defense against model changes, and so many things. Another two very important thing, that This called defense should not require any information on the learning. These are basically say that this kind of defense is universal defense, or kind of it is not required model information. This is much tougher. Or defense should not require any complete training deficit. These are the much challenging scenario. Some cross tokens. One, you define a defense for a particular system for a particular attack. Now, is it going to help in the other system for other attack? So this is called cross-domain defense capabilities. So these are the challenges, and what are the thing that what we are going to make. Okay, that challenges are there. Okay. Now next portion is mostly visual things, and this is example based thing, and so that we can understand it, that what are the major threats and in different image and video, or basically computer vision task. Okay, I'm a bit faster in the next because we have not much time. Here you can see that it is a pattern recognition example. And so you can see this is the semantic segmentation kind of thing. And you this is the some benign semantic segmentation. But you can see here that this is semantic segmentation. They said it's object detection. No, first of all, this is semantic segmentation, and you can say that this segmentation is clean level, but it's adversarial level. So this semantic segmentation is wrong actually. Okay, so this is some adversarial noise due to adversarial noise. So this is one example. Now here it is even much more severe. You can see this is the subject detection algorithm. So this is there when there is no perturbation. So every dog is as is object, it is and dog. But here it is a complete, the bounding box is also wrong and say it is a train or something person and something like that. So this happened. So this is, I'm not going to discuss everything because this but this is a very important, that is also skeleton based human action recognition, that how this is part of skeleton action being inputted for this to make this discriminator falsify, so to take the decision. So this is the another attack model on human action recognition. Here it is a very important because there is a lot of issues of you can see that ISRO or our defense organizations have a lot of this kind of thing. Mainly ISRO is basically weather forecasting or a kind of different hazard management thing. So here you can see this is the airplane, but every time this is baseball field, this is beach, this is the basketball court. Now, if we do this kind of attack, this is classified as symmetry. This is all are big symmetry kind of. So you can see this kind of problem happen. These are the example. Here also another remote sensing. You can see this is when the clean image is given for different deep learning models in AlexNet, VGG, Inception, ResNet, DenseNet. These are the very high confidence thing, but if you put this perturbation noise, then this is AlexNet, VGG, Inception, it will substantially reduce. You can say that residential is called residential thing. This is a river, this is residential, the mountain, this is beach, or of this kind of. So it's completely messed up. So this is the example. So many examples I'm not giving. This is the autonomous vehicle. You can see that this is segmentation map. Now this segmentation, the actual intended, and after injecting the noise, we can get a completely messed up image. So it's incorrect segmentation of the attack. So this is thing. This is another problem. This autonomous vehicle, that if we put this thing, you can see that this is the actual basically the predicted semantic map, and but this semantic map is complete. classified. So these are the things. So with a similar example, we already talked about this. So yeah, this is also a very important aspect. That is the facial recognition. We can say that how actually this facial recognition alters because of this adversarial with digitally generated projectable adversarial light pattern. So here it is a very important thing. I'm not going because it's a very important paper. So that some sort of uh, adversarial light pattern is being injected to this light projector thing, so that it basically gives. Yes, this is also very important that you can understand exactly what happened. That actually this is face recognition. So face recognition means that if you say that the similarity between these two, you can say definitely two different face. So average similarity is 17.8%, very low. But if you put some transferable adversarial noise to this image, so that the image similarity, that two faces are very similar, is becomes 78 point. Is a kind of a huge misclassification. They said the two images are same, where you can easily we can see that completely different. Okay, so these are the way we these are the images of biomedical imaging, where these are the fundus image. There's no DR, but it is called the DR. This is the DR means there is a problematic fix. Now it's a normal thing, but if you put as is a pneumothorax, that means pneumonia is present, and this is the benign some things, and if you put this malignant nervous nervous kind of thing, so that is the it is basically dermatology kind of thing, skin cancer. So these are the very. So what actually this what you're trying to say of last few slides, that adversarial perturbation become a serious threat on computer vision and the related areas. Okay, so this is the. So next we are going to understand different attack models. Okay, now we going to bit technical. Okay, now whatever I think most of you understand that what are the adversarial perturbation, what are the defense mechanism, what is the definition of this, and somewhat a very brief overview of this, and the major applications where is under threat under these adversarial perturbation attacks. Now we try to understand what are the different models, attack models. Okay. Okay. So in adversarial attacks is a different kind of attacks. Namely, it's called model-based attack. So some model inversion, model extraction, it's called, will come one by one. But it is not possible to go everywhere. But at least few of them we try to understand. Very important one. Then data poisoning attack and this evasion attack. So what we'll see that these are two data kind of thing. Data poisoning attack means this is the input image, we put noise, and evasion attack is at the training time we put the noise, and is the testing time. It's called white box attack. That means we attacker know the model and about a black box attacker, even they don't have any idea about the model still. So these are the basic attack variants or adversarial attack variants of to the computer vision systems. Now, first of all, we try to understand very slowly that what with our very this limited background, that whatever we have shown last half an hour or 45 minutes. On the basis of this, we try to understand that what kind of attack. So data poisoning is that this called causative attack. That it is first to understand this is on the training phase. When this model is being trained so that it is being an attack. So attackers part of the training set of the so they inject the noise, and with this adversarial example, they train. So insert malicious inputs in the training set, modify the input instance in the training set, change the levels of training. So these are the way actually they are trying to backtrack, but at the training time. Attacks attempt to influence the code of the ML model or the ML algorithm itself. So, so that is this they are trying to do. They put the malicious training data here so that they can get intended. They are intended at attack. Now another next kind of attack is called exploitatory attack or evasion attack. Popular. So when attack is done on the testing phase, it's not the training phase attack. So what? Attackers do not tamper with the ML model. So they are not doing the training phase or model, but instead they cause it produce the adversary outputs. The most common attack. So we'll see later this FGSM kind of. This is the, but most important thing that we have to understand here, that it is attack on the testing phase, and they are using different kind of way on the influence. Then they can collect data. Okay. So okay. Now another kind of information or based on that the knowing the attacker know the model or not, this evasion attack can be further classified into white box attack and black. What do you mean by white box attack? Attackers have a full knowledge about the machine learning. That is called the white box attack. Okay, that they know these parameters. Because in machine learning, if you understand that it's a machine learning model. So what does this mean? You know algorithm, you know the model parameters, you know the hyperparameters. Then that means you know. So this knowledge, if the attacker has this knowledge before mounting the attack, then it's called white box attack. So though they have access to parameters, hyperparameters, gradients, etc. That means. But in general, from the attacker point of view, this easier attack, easier to mount this attack. But on the other hand, this is called black box attack. These attackers don't have access to the ML, these parameters, model parameters, gradients, architecture, and so on. Perhaps they have some knowledge about this used ML. So what they do, they may know that this is maybe a ResNet, but ResNet is fine. They know about, but they don't know the architecture. They don't know the model parameter, this parameter, this no hyperparameter, but they don't have access to the model parameters. That is important. Okay, attackers may query the model. So what they can will come, it's very interesting. What they can take a model, because ResNet 50 is available, but some models, they put some, given some input, get some output. Based on this, it can hypothesize the model. That can be done, but the model parameters are not. Now, another very important this nomenclature is non-targeted and targeted. Non-targeted, most of the attack are non-targeted. Non-targeted means goal is to mislead the classifier to predict any level other than the ground truth level. That means there is a classifier. There is a classifier which basically trained on the cat image. They said when they are given a cat image, they said it's a cat. If it's a non-cat image, any image given, it's a non-cat. Now the question is that the way it has been done, that if a cat image is given, if it is adversarial perturbation in such a way, or inject the noise such a way, that the model said that give even a cat image given, it says a non-cat image. But it is not said what is image. If this is called non-targeted, not existing one deals with this code, because it's easy. The pattern image of a military tank, and so that model predicts it is only any other class than a military type. So only these things is not going to any other thing they can see. But targeted attack is much severe and much tough to mount also. The goal is mislead the class with the predicted target level. So given a cat image, they say no, it is not other than cat. It's a okay, it's a dog. Or say given a military tank, it's a no, it's not a military tank. It's basically a bus. Okay, so this way of partition. So when what they are going to say, that also been fixed. So it's more difficult and it's part of image and target that the model predicts is true. And part of image is stop sign, model predicts is a speed limit sign. So this is the basic idea of that targeted attack and model. Now we try to understand how actually bit we dig for a poisoning attack. So it is basically also known adversarial contamination. And this data set poisoning, algorithm poisoning, model poisoning, these are the different ways we can do. Data set poisoning, they already we have discussed. Now here, if we try to understand that what are the basic idea of this kind of poisoning attack here. That poisoning attack is by adversarial countermeasures is a security attack. That means what? If you try to understand in this figure, it's very interesting. Now this is the no poisoning case. So it's a benign case. There is no attack has been given. Is done. Now you see that this speed limit sign that is basically given by this example of red dots. It is in one side of this decision boundary and stop in other side of decision. So it is a very genuinely given or benign situation. Now we put some this just for hypothetical sake. This yellow box is a noise. Now what happened? That you see this stop sign is becoming now these four things. These are the data points are being very adjacent to this stop. So there may be a situation that this classifier may understand, okay, this stop sign is not this side of this decision boundary. Rather, it's very close to these dots. So you can put this other side of. But understand? So it misclassified as it is this kind of that the speed limit kind of that. Apart, but it is look like stopping is slightly. So this is the poisoning. Okay. So this is very easy. So this is called model inversion. We have not much time. Half an hour, I think we have. Half an hour, I think. So here also we try to some sort of. This is model based attack. Say this is the whatever we have discussed so far is basically the data kind of thing. Now it's a model based two basic types. One is model inversion attack. Sorry. Okay. Just a second. So what do we mean by model inversion? So using the model by leveraging the input output of a model, can we get some information about the training data? If we can do this, by this training data, we can mount an attack, and this is called model inversion attack. So an image is recovered using a new model inversion. This left is basically image. This using an attack by attacking this, and the training set image of the victim. That means what exactly? Because you can see that there is this input images is not open to all. Sometimes we require to get some input image. So here, so attacker is given only the person's name and access to the facial recognition system. That means the model that returns a class confidence score. And by this kind of attack, they find out what is the basic, what is the input. So this is called model inversion attack. So you can see if you go, you can these two papers also. Another important attack is called model extraction attack. That means model parameters. You know about that can be possible to is this is called model stealing. That can we get some idea about model parameters or algorithm, so that we can mount the attack. So these two called model based attack is called model inversion attack and is a model extraction attack. Okay. Now what actually try to understand bit what is model extraction attack. So adversarial reverse engineers the model, and that has been made available to the query. So reverse engineering. Now if you have given a model, that may be okay. It's a classifying cat. So what we can say that that this is a kind of sentiment analysis kind of. So I love this restaurant. It is a positive output. So it is an example of the sentence-based sentiment analysis, so that we can get this. Now, so attacker sent a large amount of queries to and get back the levels. So different type of sentences, the model, the attacker put in this model and get the corresponding sentiment kind of. So it will give this. So these queries need to be very appropriate and manage to get the level exam. As a result, these queries are now labeled. Now what happens? You see, you have a model. You have the input and output. Now what you can do? You can just change the labels and retrain the model. And this the adversary can these level queries a training sample to train their own model. So that the training is basically now done in a malicious way. So that you know the inputs, you know the outputs, and you change the output such a way that this model start create forms. So this is called model extraction attack. So what if when this that adversary want to stop paying the API? So these are the basic motivation of them to reconstruct the general behavior. So that is basically the thing. Or this is a kind of another kind of way of doing that model extraction attack. Let you are subscribe one model for you have to pay every month. But then if you find out you write your own that model by reverse engineering. No, I don't want to subscribe. Now we have a model. So this kind of motivation we are saying. Now stealing the model is the stepping stone for the other attacks. So this is what we have said. And having the copy of the model knowing its representation makes model inversion gathering. Generating the adversarial example is much easier. So we can get, if we have a model, if you have input, we can easily use we can get some other outputs, or we can very easily generate the adversarial. Okay, so these are the more or less model extraction. Now this is the model inversion attack. So it's another type of thing that what I say. So it model is basically attacker try to leak the information about the training dataset. They want to know that what are the training dataset. Attacker does not need to access the dataset, just the model. Without they don't have the dataset, but they have model. And so what how it works? Attackers can query some model by giving its input, and definitely they get some output. Now use this output to estimate the input was from the training data. Now, if in this taking this output, can we hypothesize it? That what I say. This specifies that depends on the type of model, linear regression is something that it is linear regression is very effective way. So facial recognition. Attacker has access to the facial recognition model that will take the images and output with these things version and with the confidence. Now with this thing, it can do, the attacker can generate faces and check out. And we do the reverse engineering, do the reverse thing. Use the gradient descent to generate the better and better faces. So now what is basically they're doing to do output is, you see the gradient descent is the optimization that we know in every our machine learning understanding. The gradient is optimal algorithm that finding a local minima of. Now in this case, what they are doing, this input are the various parts of the image and output is the confidence score. Now if we do this, say the want to loss of this and find a minimum rather than the maximum. So the idea is basically, can in this way they try to hypothesize it. The changing something made in confidence a lot better, keep changing in that itself. So depending on the confidence score, they try to find out images. Now exactly this, and it looks 1 for 4 second to generating a face. Reconstruct is not perfect, definitely the reconstruct is not perfect. Now nowadays another very important thing, it can easily be done by a generative model. So GAN this kind of thing also can be used. Okay, so what we have discussed that now only this is not possible. It's a lot of 100 of attacks. So only one attack I just put. This is very important attack, and we this whatever we have said so far, it's a bit superficial. Now in this particular FGSM, we try to, as much as possible, we try to deep into this. We have not much because there is a question and says time is required. We have already, it is 7:10, I think. So another 10 minutes we'll discuss, and then another last 10 minutes we'll go for a question and answers. Doing very fast. So what is the basic idea here? That this paper is the Goodfellow paper in 2015. Now what they are doing, this adversarial image, that means what the image is patterned, is being designed in this way. That is epsilon dot sign of this is gradient of this gun, and this is the L is kind of a loss, the difference of h of x. H is basically the this function, this model function. This you can say the hypothesis also you can say, or model function. And y is the target output. And this loss is basically the cost function. That means loss, this difference between these two. Taking the gradient of this loss and take the sign, and it is kind of multiplied with this epsilon, this noise magnitude, and if it add to this x and to this. Now what is the, this is okay, you can understand for mathematical why they are doing it. I'm not going details. So this is the way, this is the basically the FGSM method. Okay, that we understand that, okay, this kind of things we have added. But why? Now the thing is here that if we recall this neural net training based on gradient descent, what actually happened there? That these network parameters were iteratively change until a minimum of the loss function is reached. That we generally do in error surface. We try to try from a basic way any random location. We do this weight changing such a way we can get the global mean. And since for linear regression kind of thing, there are surface is convex, we can easily get this. Now, this is general case. Now, what happened to this FGSM? Actually, what we do that we do some kind of whatever in that case of a normal classification, we are trying to do the local. But if we go for what we want, the classifier should misclassify. So to minimize the loss function, weights are changed in the opposite direction. So in this way, in the normal case. But if GSM do the reverse. So what they do, if they do the reverse case, that gradient is basically not minus, now it is a plus. So the idea is basically this, that in general, this gradient descent is try to find out the local minima. So that error is being reduced so that we can correct classification. If we do the reverse, if we increase the error so that the chance of misclassification is. So this is the idea, basic idea. It's not that much easy, but this is the main idea behind it. Okay. So you can see this is the car image, this is the original image, and this is the corresponding adversarial image, and we can get this idea. Okay. Okay. Now, quickly, what are the different strategies we have? So these different strategies is basically adversarial sample can cause any ML algorithm to fail. So how we can put some mechanism so that we can do this. Okay. What are the challenges? So defense against diverse attack types, defense against machine learning, similar thing. But this less computational time, which already we have discussed. So we have not much time. So okay. So generally two type of defense. One is model specific, when we know the model. One is model agnostic, that we don't know the model. So any attack, aim to defending any attack, aim at defending in some specific attacks. So you can say you can go to these are the very good papers that I have just put it here. So you can go if you want to go in details, you can go. But first of all, to understand what is this, so first adversarial training. Now adversarial training, we have to generate the adversarial examples. So how we get adversarial examples? We can put some noise such a way that it misclassified. So learning the model parameters using the adversarial samples is referred to as adversarial training. So if we have a basically adversarial samples, that means you have a injected or part-trapped images, and by part-trapped image you retrain the model. This is called adversarial training. So the training data set is augmented with adversarial example in known types of attack. So these are the basic idea. Now what happened if you put only adversarial example, so that the accuracy of the classification, normal classification, is reduced significantly. So what strategy generally being used? That train the model with from the scratch with a mixer. So it's a kind of vaccination. Now, what is the basic idea here? If we know that exactly why we are vaccinated, we put a small dose of infection to our, that is not get some harms to our, but our immune system is actually prevent. So they know how to prevent. Here exactly some kind similar. If we know the adversarial examples, that means we retrain the model with this or fine tune the combination of the actual things, or and even with a kind of adversarial example, if we labeled it is the proper. So even if we injected this thing, initially it was been given, but now we can say no, it is also panda. So this is the basic idea. So this is the model specific defense, this adversarial training that we have. These are the, you can say, this original data set. Now put some adversarial, this kind of FGSM, JSMA, CNW, and this, and all this data are being put in and do this kind of training. So this is called adversarial training. So that now what model you get, that is not so easy to fool. Even any of this attack we put, they can know, no, this it is a noisy, but its level is this. Okay. So we don't have much time. So we briefly just said whatever we have done in our in our lab, and just it is a lot of things. So I just give an overview of this. If you're interested, you can talk later. So that this present research investigate this adversarial learning. So what we are doing a similar thing. This was a project. So we do the things. We first use a adversarial attack. So we have shown that this kind of attack is a very advanced technique. We use a clip guided generator for this adversarial attack. I can show you somewhere. This is the attack. Actually, we use clip for this generating these loss functions. And this general model, we can resiliency map and noise. And this, again, these two we fuse and to get a perturbation, this is noise matrix, and add it to the actual image to get this, the adversarial image, and then train with the surrogate model. So these are the noisy model or something. This and there is you can see the Z and Z bar. These are the feature vector from perturbed image and the raw image, actual image. And for this training, what loss function we have? This MG, these are the these two existing loss, and another is the this kind of clip model, that contrastive loss we have used. That p-text mean is basically, so we can take this is a clip image encoder, and this is a kind of text from class labels, and we can fuse these two, we get this p-text. And this we use as a contrastive loss, and this loss we have used between these two. So we get this attack, so that it looks a very natural, and it basically you can say as a adversarial examples, and a very hard, a very sophisticated. So this is the one thing. Now another thing, we come to adversarial detection. This is very important. I know somebody said that image, this given image, in human eye, it is the same, nothing. So can it be possible to detect that this image is perturbed? So this particular term, that this is our another work, and you can see here that the building on this this is again best work, that we have a generator. This is our generator. I'm not going details. So generator, the perturbed examples, we get a perturbed example and there's a example, and there is a train discriminator. This is actually the classifier who said that he can do that. This is a perturbed example, this is a real example, so that it trains such a way it can differentiate is a real example of perturbed example. And this is basically being strengthened by doing a generator. It's a very sophisticated generator, so that it create this example looks very natural and very close to real example, so that the strength of this, even if the discriminator can use a real example. So this is the basic idea of this. Now another adversarial defense is basically we can do a lot of things on defense mechanism. This is the one adversarial defense Here you can see that we generally this work is very good, but what we have done that we given attacked image, can we get back the denoised image? And using this denoised image, we can retrain this model so that we can get back. So this is the, I'm not going into details because we have. So this is all the contrastive learning based adversarial inference. And this is this capture GAN. This is globally connected and trainable article find admission GAN. Here is also we have used this kind. So with this, I summarize that what we have discussed in this last 1.5 hours, just 1.5 hours. So some brief introduction of adversarial perturbation. What are the threat areas and threat models, defense policies, and whatever our research and current some research scopes. So that we can discuss. So well, thank you very much for your patience. Now open to take some questions. So if you feel free to ask. Thank you very much.